All right, today we're going to talk about surface area and volume. The topics we're going to cover today you covered in geometry. There might be a couple of extra pieces with surface area that you haven't seen in a while. The best part about this section is most of the formulas that you're going to need are provided for you in your IB formula booklet. It's just a matter of knowing that they're there and recognizing which one to use. So I'll put a big note at the top of my notes that says your formula booklet is your friend. So go ahead and take out your formula booklet. You're going to need that for today. I've been going through and sort of checking off the ones that we've worked with. So we started out, here's your prior learning formulas. So some of these are going to become useful in this chapter since we're talking about geometry. So they give you area of a parallelogram, area of a triangle, they give you area of a they call it a trapezium, so that's a trapezoid. They give you area of a circle, circumference of a circle, and then these two that you worked with in geometry. Okay, so this prior learning has some of our two-dimensional geometry things like area, circumference that you might need. Topic 5 is your geometry topic. So this is where we're headed next, and some of it should be familiar to you at least. So this is your slope formula, equation of a line. We've got law of sines, law of cosines. This will be new. And then this is where we're focusing in today. So surface area and volume. So they give you a bunch of formulas depending on what type of shape you're working with, and you'll want to keep going back to these when you're working on your homework on this section. So let's take a look about how a problem could look. So let's say find, I'm going to abbreviate surface area and volume for each. And now we have to be great drawers. So we're going to try to draw a nice little rectangular prism. Okay, so there's that. We have our little hidden lines back here. And I'm going to label some of my sides. Now remember from geometry that if a side length has the same number of tick marks as another, it means it's the same. So if this has one tick mark and so does that means they're the same length. If this has 2 and that has 2 and that has 2, they're all the same. Okay? So you'll see in your book they put a lot of tick marks around. If it has the same number of little tick marks along a segment, that means it's the same length. If they're all the same length like that, we've got a rectangular prism here. So the first thing we need to find is surface area. Surface area is a little bit tricky because you have to break it down into each shape. So we need to find the area of every face. So this is a rectangular prism. It has 6 faces, top, bottom, and then 4 around the middle. So 6 total. And we're going to break it down into each type. So I'm going to start with this front because it's just right there. It has a front, but it also has a back that's the same size. So it has 2 of those. So if I break that off to the side here, I've got a 10 by 7 square. Area of a rectangle is length times width. So that's 70. We have 2 of those. So far we have this number. That takes care of the area of the front and back face. Surface area is just the addition of all of the areas of each face. So now I'm going to look at another face. How about this one? So this side face is 7 tall and 5 across. That one's going to match the one over here. There's 2 of those. So when I do my 7 by 5, same thing, length times width, 7 times 5, which is 35, and we have 2 of those faces. And we do the last thing with our top and bottom face. So we've got this face here, and then the same one on the bottom. This is 10, and this is 5. So length times width, 10 times 5 is 50, but we have both a top and a bottom. So our surface area for this shape is just the addition of these. So surface area equals 40 plus 70 plus 100 which is 310. Now, if I was a good question writer, I would have put units on this. So let's say they're all in inches. Then your surface area is in square inches. Okay, so we broke it down to its little two-dimensional faces and found the area of each. Area of a rectangle is just length times width, taking note of how many there are. Volume for a rectangular prism is length times width times height. So this is for a rectangular prism only. So we have our length, width, and height as 10, 5, and 7, and we just multiply those together, which gives you 350. When we're talking volume, we are in cubic units. It's actually the space inside. How many cubic inches of space are inside? Okay, 350 in this case. So some of our shapes are nice like that, like a rectangular prism. Others get a little bit trickier. So we're going to draw a pyramid very carefully. We're going to very carefully draw a pyramid. So it's going to go like this. There's my pyramid. This pyramid has a square base, so I'm going to indicate that by marking the bases as the same length. That is a square base. These are 90-degree corners. And we've got a couple of pieces of information. So this is 1.6 meters. They give us what we call the slant height. So the slant height goes along the outside. So it starts here and it goes along the outside. Does not go directly up and down. It's not like this height. It's actually along the edge. If you imagine you couldn't get inside of this pyramid and you had to measure along the edge because it's solid. They tell us this is 3.1 meters. And we're asked to do the same thing, surface area and volume. So our surface area is broken down into the area of each of the faces. So I'm going to start with, let's see, we're made up of a square on the bottom, and then 4 triangles that go around the outside, 4 triangles here. So why don't I start with the square, and then see what we can do. So for the square, the base, it's 1.6 by 1.6, okay, we marked it as a square. Area of a square is just length times width, so 1.6 times 1.6 gives me 2.56 square meters. And now we have to look at our triangular faces. So this triangular face, draw it a little bit bigger because we're going to have to do a little math. We know some information. We know this is 1.6, and we drew that line as 3.1. Area of a triangle is considered in our formula booklet as prior learning. So if you need this, it's available to you right here. Okay, under prior learning, area of a triangle is 1/2 base times height. So this triangle is 1/2 base times height. Our base is 1.6, our height is 3.1. We multiply those. 1/2 times 1.6 times 3.1 is 2.48. And we have 4 of them. Multiplying by 4 accounts for the fact that we have 1, 2, 3, 4 of those going around. Times 4, 9.92. These together create the surface area of the entire shape. It covers the area of every face. So our surface area here is those added together, which is 12.48 square meters. So that would be the area of your outside faces. It's like how, if you're going to paint it, how many square inches do you need? How many meters here? Square meters of paint. All right. So volume for this. So this is surface area bubble. Our volume formula is provided inside of our booklet. So I told you this booklet would be useful. So topic 5 is your geometry topic. And volume of a, where is it? Pyramid. Okay. So we can read what it says. It says the volume of a pyramid, which is what this is 1/3 A times H, where A is the area of the base, H is the vertical height. Vertical height. Now notice there's another one that says slant height. So vertical height versus slant height. What we have here is our slant height. It goes along, it's slanted, it goes along the edge of your shape. The vertical height is how tall the actual image is. So, like from the top to the bottom, how tall is it straight up? Okay, altitude would be another word. We're looking at, we need to find the height of this shape. So, let's see what information we have that might help us find the height. I'm going to write down my volume formula and then try to figure that out. So 1/3 A times H. We can, just before we get there, we can do the area of the base. The base is a square, so it's just length times width, which we have the length and width of the square. We're just missing the height of the shape, which is our blue line. If I draw this triangle, and we've got the blue height that I drew, and I go over to here, I've made a right triangle. The nice thing about right triangles is we have a lot of formulas or processes that allow us to find side lengths in right triangles. So, this slant edge, I'm going to draw that triangle off to the side. The slanted edge is 3.1, and this little pink side is half of that, because the rest of it would be here, and then that's the other half. So half of 1.6 is 0.8. We have two sides of a right triangle, and we want to find the third. So for this, we can use the Pythagorean theorem. So let's call that x, that's what we want to find, or you could call it h, because it is the height of your shape, which is what you're trying to find. So h squared plus 0.8 squared equals 3.1 squared. Some squaring to do. There we go, 0.64 for that. We're going to square 3.1, 9.61, subtract the 60.64 over, h squared equals 8.97, and then we square root. So our height is 2.995, okay? So sometimes we have to use other stuff that we know in order to help us find pieces. So when we plug into the volume formula, 1/3, we have the length and the width, 1.6 times 1.6, because that's the length and the width of the base. And the height is what we just found here, 2.995. Now, anytime you can keep numbers in your calculator, it's going to make your answer more accurate. So this number is actually this number. Okay, this is just rounded. So instead of putting it at the end, I'm just going to, you can multiply it there, or go 1/3 times 1.6 times 1.6 times your last answer. Okay, I got that by doing second minus right here, second minus. That just helps you be more accurate and saves you a little time from having to type in a bunch of decimal places. So our volume for this figure, the space inside, is 2.5. I'm going to do 3 sig figs for practice. So 2.55, but that 5 rounds it up to a 6 cubic meters. Okay. Might have been a while, but those are both topics from geometry. Now, not all of our shapes have nice flat faces. There's a lot of shapes, three-dimensional shapes that we work with that have curved faces. So how do we handle those? Well, lucky for us, your formula booklet has formulas for these. So, curved surfaces. So our main shapes that we deal with that have curved surfaces: cylinders, spheres, and cones. So we have 3 different formulas that deals with the surface area of each of these. Your volume formulas are also inside the book, but you probably have a little more practice with those. So for the first one, our cylinder, in your formula booklet, there's volume of a cylinder, but we're talking surface area as well. So area of the curved surface of a cylinder. And I'll write down both. So for a cylinder, they give us the volume, pi r squared h, and I always do SA, they just use an A. Surface area is what we're working with here, is 2 pi r h. Now, always note, this is the curved area only. So that does not include your flat top and bottom. You have to also include those if it wanted you to. It's the curved spot, okay? It's the curved around. For your sphere, they also provide formulas for this. So for a sphere, volume is 4/3 pi r cubed. And your curved surface area, which your whole sphere is curved, so that does cover everything, is 4 pi r squared. Surface area of a sphere, there it is. Volume of a sphere, okay, so those are both provided. And then for our cone, same thing. They provide volume of a cone, and they provide surface area, curved surface area of your cone as well. So this, once again, curved surface area only. This has a flat bottom, so for the total surface area, you'd have to include that. I want to label these pictures so you know where these values would come from. So for your cylinder, this is your radius, halfway across the circle on the top or bottom. And this is your height. And that's all radius, height you need. For your sphere, the only thing you need is the radius. So from the center to the outside is your radius. And the cone is where it gets a little tricky. So your radius is here across the bottom. That's your radius. And then we have an H and an L. If you read in your formula booklet about the H and the L, right here it says L for area of the curved surface of a cone. L is the slant height. H is the vertical height. So on a cone we have both a slant height, this is your slant height, L, and we have a vertical height, H. And we need to make sure to keep those separate. They're different values and they're used in different ways. You want to make a big note that for these formulas, those include only the curved surfaces. They do not include flat bases of cylinder or cone. So be very careful with that. You have to remember to also include those if it asks. So for the following questions, we're going to find surface area and volume. And surface area, we want the total, not just the curved. We want the total surface area and the total volume of the shape. Okay. So here we go. Question 3. We're going to make a cone. Okay, I'm going to give you some information. .2 centimeters there, and I drew all over this. What's the other piece I wanted to give you? This. .5 centimeters for that height. All right, we can start wherever we want, surface area or volume. I'll just start with surface area. Our surface area is going to have two different things. You've got the area around the cone, the surface of the curved area, and then we have our flat bottom. So for surface area, let's break it down. Curved surface area. Now this is where our formula comes in for a cone. curved surface area is this one, pi r L. Then we also have the base, which is a circle, and this is 7.2. So those are the two pieces we've got. So for our curved surface area around the cone, we need pi r L. Let's see what we've got. Pi. Now, 7.2 is not your radius. It's actually all the way across, so it's your diameter. So to find your radius halfway across, we cut that in half. So 3.6 is your radius here. And what we don't have is our L value. So when we read about L, it says L is the slant height. This is your L. We have our actual height of the shape, vertical height. We do not have our slant height, so we need to find it. Now this breaks down into a nice right triangle where we know two pieces of information and we want to find the third. So we're going to use a little Pythagorean theorem. So let's find L. So these are the sides. This is the hypotenuse, legs, hypotenuse. So we'll do 5.5 squared plus 3.6 squared equals L squared. 5.5 squared plus 3.6 squared is 43.21, and then we square root. 6 point, I'm going to leave a couple more decimal places just because it's not my final answer. There's my slant height L, 6.5734. That is the number I use in this formula, not the 5.5. This is one of those instances where I've got that number in my calculator, so there's no point in rounding. So I type in pi times 3.6 times my last answer. And we get, for the curved surface area, 74 we'll go with 34 for now. This would be square centimeters. So we're finding surface area. For the area of the base is a circle. Lucky for us, if you forget area of a circle, and they provide the formula, pi r squared. We know our radius is 3.6. So pi times 3.6 squared is 40.72, and we add those together. (115 square centimeters total. So if you plan to paint this entire cone, all the curved sides and the base, there would be 115 square centimeters of space to paint. Now we have to find the volume, which turns out to be, this is our surface area, turns out to be a little bit easier for this. We can always rely back to our formula booklet, which provides our volume formula, which is 1/3 pi r squared h. We already have all of these values, so 1/3 pi. Your radius is here, 3.6 squared, and h stands for vertical height, which is 5.5. Multiply all of those together, and you get 74.6 cubic centimeters for your volume. All right, we got one more question to deal with this. The IB exam loves to, instead of having like direct numerical answers, they love to have variables in the problem to kind of, throw you off a little bit, or, increase the rigor of the question. So some of these problems, instead of having direct numbers, we'll use variables. So write an expression for the volume and surface area of the cylinder. We want to do the total surface area, not just the curved. So here's my cylinder. I'm going to say it's 12x high and 5x across. We are going to use those values instead of actual numbers whenever we're doing our calculating. So, we have our surface area formula on the front, or on the last page for a cylinder. Remember, this is just a curved surface area. So, curved surface area of a cylinder is 2 pi RH. For our bases, there are 2 of them, and they are circles. Pi r squared gives you a circle, and we have 2 of them. So our formula for the entire surface area of the whole thing is our curved surface area plus the area of our circular bases. This is a formula for the actual whole thing. We're going to plug in the values that we know. So 2 pi r is the radius, 5x, h is the height, 12x, and r is the 5x, so 5x squared. And we simplify. So we can't add them together yet because they don't have like terms. So we're going to type them in. We're going to just put everything together. I'd leave that pi alone. So we can multiply the 2 times the 5 times the 12 to give us 120. So these numbers multiply to give us the 120. Then we have the pi, and x times x is x squared. Plus, when we do 5x squared, 5x times 5x is 25x squared. Now that we took care of that, 5 times 2 is 50. And these, although it's kind of weird, are actually like terms. We have 120 pi x squareds plus 50 pi x squareds, which is 170 pi x squareds. This is not, although it's all put together into one question, none of this is new. You have found the curved surface area and total surface area for a cylinder before, using your formulas. You've substituted expressions in for variables, and this simplifying is just following our PEMDAS and making sure we do everything in the right order. So an expression for the surface area of the cylinder would be this. Let's do the same thing for volume. Volume of a cylinder is a little more straightforward. Pi r squared h. Pi r is 5x squared. The height is 12x. 5x times 5x is 25x squared. Leaving the pi alone because I don't want to have to, it's an icky decimal. The 25 times the 12 gives us 300. We've got x squared times x, which is x cubed, and I probably should have put the pi in between. There's nothing wrong with that, but a better answer would be 300 pi, leaving your variable at the end. That would be an expression that we could plug in different values of x, and that would give us the volume. All right, get started on your homework. I did on this unit give you guys an extra work day here in a couple days, so pay attention for when that's coming up. I wanted to teach these 2 lessons together, and the same thing with the next set, but I know it's a lot of information at once. So it should give you just a little bit extra time to work on each homework assignment. Thank you for watching, and please let me know when you have questions.